Okay, now let's determine the center of mass of a uniform thin L-shaped construction brace. So we have this L-shaped pattern here, and we want to find the center of mass. Now, if it was just a bar like this, it'd be pretty easy. It'd be right about there. Or if it was just this bar, it'd be right about there. But what if we're looking at both of them combined? Where's the center of mass of the whole thing? Your gut tells you it's somewhere in between, which is kind of in the middle of nowhere. Let's find out exactly where it's at. Okay, so here's the dimensions, zero point 0.2 by 2.06 and zero point 0.2 by 1.48. So I'm going to put a coordinate axes in here, which is what you have to do to solve these problems. And you can put it in here anywhere. I could have put it down here, over here, anywhere. I'm going to put it right here. So the center of mass for A is pretty easily found, and for B is pretty easily found. I'm going to go ahead and do that. For A, it's going to be half of this distance and half of this distance. So 1.03 and 0.1, right about there. For B, same idea. Half of this distance and half of this distance. However, since I'm saying the origin is here, it's going to be zero point 0.1 back from this edge. So it's going to be at 1.96, and it's going to be down half of this distance, which is negative 0.74. That's just by where I chose 0, 0 to be at. Now, if I want to find the mass of A, it's a lot more complicated. I'm going to rely on your memory a little bit. If you remember from chemistry or maybe one of your earlier science classes, mass is given by the volume times its density. This V stands for volume. This funny looking P stands for density. So volume times density is mass. How do you find volume? Well, you multiply all the dimensions together. 2.06 times zero point 0.2 times the thickness of this thing. That's what the T stands for. I don't know the thickness. I don't know the density. Two unknowns. That's usually a little bit bothersome for students, but trust me, you'll see in a little bit that it goes away. Let's do the same thing for mass B. For mass B, we have again the volume times the density, which would be 1.48 times zero point 0.2 times some thickness T, and then multiply that volume by its density. So let's use a definition for center of mass that we just found. And that would be the sum of all the individual mass elements times their position divided by the total mass. Well, we've got two elements here, A and B. So we're going to have to add up both of those products of the individual masses times their positions of their center masses. So that's going to be the mass of A times the position of A in the x direction plus the mass of B times its position in the x direction divided by the total mass. So that's the idea. Now let's see what it looks like when I plug into that. So it's going to be the mass of A is 2.06 times 0.2 times the thickness times the density. That's what we said here. And its position, that's the XA, its position we found was 1.03. Let's do the same thing for B. The mass of B is 1.48 times 0.2 times the thickness times the density, right there. Times its position. Well, its position in the x direction is 1.96. And then I have to divide by the total mass. So I'm going to add both of these masses together for A and B. What I want you to notice is that there's a TP, thickness and density, in each part of the numerator and each part of the denominator, which means I can factor out the thickness and density in both of them, and I can cancel it. So I'm just going to cancel it right off the bat here. It cancels. Now I can just plug and chug, and I get the center of mass in the x direction being somewhere about 1.42. So probably about maybe, let's see, 1 would be right about there. So 1.42, maybe somewhere in here. So somewhere along this line is the center of mass. Definitely not up there, but somewhere along this line. I have to find the y coordinate of the center of mass now. So let's go ahead and look at that. Still same formula, now it's just in the y direction. And so that's going to be the mass of A times the y coordinate for A. So the y coordinate for A is the 0.1. And the mass of B, which is this over here, times its y coordinate, divided by the total mass. Add both of those together. This is what it looks like. Notice I have a thickness and density for both of them. And I can cancel it out. And then simplify, and I get negative 0.25, which means the center of mass of this thing is right about here. This is a little bit different than the meter stick, because the meter stick, you can find the center of mass really easy. You can balance it on your finger. You can't balance this on your finger because there's no material there to balance it on. That's where the center of mass is, though. In other words, if you were to throw it through the air and it would tumble, that center mass would still trace out a parabola. Or let's say you slide it along the floor, and so it's going to tumble along the floor. The center of mass would be traveling in a straight line because of inertia.